In this lecture, we are taking up grade 10 mathematics. Hello everyone. Today we are taking up question number 4 of exercise 2.1 of grade 10 mathematics, which says determine whether the following quadratic equations have real roots, and if so, find the roots. So let us try the first one. That is x square plus 5x plus 5 is equal to 0. Let us mark this is our first equation. Whenever you are asked such type of question, so you must go to check what is the value of the discriminant of this quadratic equation. For that purpose, we compare equation 1 with the standard form of the quadratic equation. That is, with ax squared plus bx plus c is equal to 0. So we see that here a is equal to 1, b is equal to 5, and c is also 5. Now we are familiar with the expression of the discriminant, that is b squared minus 4ac. Now substituting the values of a, b and c in this expression, we will find the value of the discriminant, and then we will decide whether the roots are real or not. Now let us draw a glance on the value of the discriminant, which is, let us denote this discriminant by the capital letter D. So D is equal to b squared minus 4ac. Now substituting the values of a, b and c in this expression, this gives D is equal to 5 squared minus 4 times 1 and 5. Now further simplification gives 25 minus 20. So 25 minus 20 gives 5. As we see that the value of the discriminant is greater than 0. Greater than 0 means the value is positive. And we know the result. If the value of the discriminant is positive, then the roots will be real. So this is the first part of the question, that we had proved that the roots of the equation will be real. Now let us verify this statement. If the value of the discriminant is not a perfect square, then we cannot solve the given quadratic equation with the help of factorization. So for its solution, we must go to use the quadratic formula or the computing square method. So we are going to solve this with the help of quadratic formula. X is equal to minus 5 plus minus under the radical sign 5 square minus 4 times 1 times 5 whole divided by 2 times 1. Further solving gives minus 5 plus minus under the radical sign 25 minus 20 whole divided by 2. It gives minus 5 plus minus under the radical sign 5 whole divided by 2a. So here we have proved that the roots are real, that is minus 5 plus under the radical sign 5 divided by 2, and x is equal to minus 5 minus under the radical sign 5 divided by 2, which are pure real numbers. Hence, the result is obtained. Now coming to the second part of this question, that is 4x squared plus 12x plus 9 is equal to 0. Say this is our equation 2. On comparing with the standard form of the quadratic equation, we obtained that A is equal to 4, B is equal to 12, and C is equal to 9. Now let us draw a glance on the value of the discriminant. Let us denote this discriminant by the capital letter D. So D is equal to B square minus 4AC. Now using these values in the discriminant, that is D is equal to B square minus 4AC. So we have D is equal to 12 square minus 4 times 4 times 9, which on simplification gives, thus D is equal to 144 minus 144. They cancel out each other and we get D is equal to 0. As we know the result, if the value of the discriminant is greater than 0 or equal to 0, that is, if it is either positive or 0, then the roots will be real. Here in this case, the value of D is 0. Hence we conclude that the roots will be real. As the discriminant is a perfect square, so we can solve the given equation by either of the following method. That is by factorization, or by using the quadratic formula, or by completing square method. So here we choose the factorization method. Now we are factorizing the left hand side of this equation, that is 4x square plus 12x plus 9, which gives 4x square plus 6x plus 6x plus 9 is equal to 0. Now here we have 4 terms. So in the first 2 terms we have 2x as a common factor, while in the second 2 terms we have 3 as a common factor. So taken out these common factors, we have 2x into 2x plus 3 plus 3 into 2x plus 3 is equal to 0. Here again 2x plus 3 is a common factor. So we have 2x plus 3 into 2x plus 3 is equal to 0. Now by zero product property, we have either of the factor were equal to 0. That is 2x plus 3 is equal to 0 or 2x plus 3 is equal to 0. Now these are the linear equations and we can easily solve them. That is, we have 2x is equal to minus 3 or x is equal to minus 3 divided by 2. The second equation also gives the same root, that is minus 3 divided by 2. Hence, this verify the statements that the roots are real. The third part of this question is 6x square plus x minus 2 is equal to 0. Let this is our equation 3. Here I am comparing with the standard form of the quadratic equation. We find that a is equal to 6, b is equal to 1, and c is equal to minus 2. As the discriminant is d is equal to b square minus 4ac. Substituting the values, we have 1 square minus 4 times 6 times minus 2, which gives 1 minus multiplied by minus gives plus. So this gives 24 times 2, which gives 48. Thus, the value of the discriminant is d is equal to 49. Now let us draw a glance on the value of the discriminant, which is greater than 0, that is positive. As we know the result, if the value of the discriminant is greater than 0 or equal to 0, that is, if it is either positive or 0, then the roots will be real. As the discriminant is a perfect square, so we can solve the given equation by either of the following method. That is by factorization, or by using the quadratic formula, or by completing square method. So here we choose the factorization method. let us factorize this equation, that is 6x squared plus x minus 2 is equal to 0. So we will split the coefficient of x, that is 1, into two parts such that their sum or difference is equal to 1 and their product is equal to minus 12. So clearly those factors are 4 and 3. So we have 6x squared plus 4x minus 3x minus 2 is equal to 0. Here we have 4 terms. In the first two terms, we have 2x as a common factor, while in the second two terms, we have minus 1 as a common factor. So taking out these common factors from the given terms, we have 2x into 3x plus 2 minus 1 into 3x plus 2 is equal to 0. Here we have 3x plus 2, again a common factor. So taken out this, we have 3x plus 2 into 2x minus 1 is equal to 0. Now by zero product property, either 3x plus 2 is equal to 0 or 2x minus 1 is equal to 0. Now these are linear equations and their solutions are x is equal to minus 2 upon 3, while the second is x is equal to 1 upon 2, which verifies the statement that the roots are real.